Hey guys, it's EJ with Blockpad, and in this video we're taking a look at the summation function. Now, as a little prerequisite to this video, summation uses inline functions as one of the inputs. So if you're not familiar with those, I suggest go watching our video on that, which I'll put a link to that in the description. Another thing is that for some of these examples, I might move them a little bit quickly. So for that reason, I'm going to share this file in our example file so that you can go look through it at your own pace. So with that said, let's get into it. The summation function is going to sum up a series of numbers from a starting number to an end number incremented by 1 and defined by a function that you provide. So in the most basic example here, we're going to sum the numbers from 1 to 100. And if I double click in here, you can see first I have my inline function of just k maps to k. So k is going to be that specific number in the series. And we're going to go from 1 to 100. And now that's going to do the same exact thing as if I had a linear series from 1 to 100 and I took the sum of that linear series. Now for something a little bit more complex here, I have an example of the Basel problem, which is this mathematical sum of a series that will converge to pi squared over 6. So if I double click in here, you can see my formula n maps to 1 divided by n squared. So that's my inline function. I'm going to go from 1 to 1,000. And you'll see that as I make this number bigger, so 10,000 or 100,000, it's going to get closer to this pi squared over 6 value that I have just calculated with ordinary Blockpad formulas. So from here, I think you can get a pretty good idea of just this simple one variable inline function here. So I can do pretty much anything here. I can say perhaps the square root of n, and then add in, and then all of that's just going to be basically what you would do with n. You could also, for example, have an outside value, say a equals 10, and then incorporate that in any kind of way. So I might here have a times, and all of that's just going to be basic Blockpad stuff. So another use for summation is that you can cycle through the values in an array and sum them all up using summation. So the simplest example of that is just to sum each and every value in an array. So here, if I click on this formula, you can see for my inline function, I have I maps to array 1 with parentheses of I. So what's going to happen is for each I value in this sequence for summation, I'm going to get that relevant index in array 1. I'm going to start with 1 because when I use parentheses here, it's indexed to 1. And I'm going to go all the way to count all of array 1. And that's just the number of items in the array. You can see I get the same answer if I just take the sum of the array. So just a slightly more complex example of that is I'm going to do that same exact thing, except I square that value. And so then I get the sum of squares. And so you see I get the same answer here as sum squares function. Now to take a dive into something a bit more complex, here I have an example of nested summation using the summation function. So the way you're going to do nested summation is you'll start with the regular summation function. And then when you define this inline function, inside of that, you're going to use another summation function. And then for my second inline, I'm going to define this summation function using both of these I and j. And you could keep this going. You could do summation of I maps to summation of j maps to summation of xyz and so on and so on. But this is just double. And so here I have square root of I squared plus j squared. And then I have from 1 to 5. And that's going to correspond with the j value here. And then after that, I end that inside summation function. This is going back to my first summation function. I'm going to start with 1 and go to 3, and that's going to map with I here. So I'll press enter, and you can see I have I equals 1 to 3, j equals 1 to 5, do this function and sum it all up. And just to kind of illustrate what that's going to look like here, I have the make array function and I have r and c. And remember, these are indexed to 0. So I have r plus 1 squared and c plus 1 squared. And so this is an array that's sort of corresponding to what this nested summation is doing. And then when I take the sum of that array, I get the same answer here. Moving on, I can sort of combine those last two examples where I can do nested summation and array indexing on a 2D array. So again, I'm going to have this nested summation. And then for my parentheses indexing, I'm going to have parentheses of I comma j, because those are my inline function variables there. And that's just going to be the row and column indexing base to 1. And again, I go from 1 to the columns of array 2, and that's going to correspond with the j value here. And then after that, I'm going to go 1 to rows of array of 2 corresponding to the I value there. And if I go through each of those items and square them and then sum it all up, then I'm going to get 90 as my answer, which is the same as if I just took sum squared of array 2 here. So that's all of my summation examples for this. I hope that what I've got here is pretty generalizable for what you might need to do with summation. On one last point, I wanted to point out that summation is really a special case of the reduce function. And I point this out not to suggest you should use reduce instead of summation, but that reduce is available to you as a sort of more generalizable summation. So to sort of illustrate that, I have this Basel problem example again, and that's going to be the same as this formula using reduce. So I'd have reduce. My array is linear series from 1 to 100. And then my initial value is going to be 0 because I'm going to be adding on to that. Then my aggregate function, which is an inline function with an accumulator, which is just all of my previous values, and n, which is the value in my array that I'm doing next. So accumulator plus, because it's going to be doing summation, and then this 1 over n squared. And so when I do that, I get the same answer as summation. So perhaps, obviously, in this particular case, I would reach for summation and not reduce. You get the nice mathematical display. It's more concise. It's much simpler. But I wanted to put that in front of you guys as just another tool in your toolbox using Blockpad. And with that, that's all I've got for you guys today. Please let me know if you have any questions in the comments. Thank you.